Hi, this is Nimla Rednam. In this video, we are going to start the topic Algebraic Expressions and Identities, which is the 8th chapter from NCERT textbook class 8. Now, in the previous videos, in the second chapter, Linear Equations in One Variable, I already explained what is a linear equation. We started from a single number and then we moved on to variables and terms and so on, right? So, we arrived at algebraic expressions there, and then we went one step ahead to get a equation and then a linear equation. So let us do that one more time. So what I'm saying is, if we have, let me write the heading, algebraic expressions, right, and identities. Okay, so here suppose I start with a number. You know that this is a number, right? Now if I multiply it with a letter x, now this is the variable part, then this becomes a term in algebra. That means that I have a variable in the sense I can assign any value to that variable, right? Now this together is a term. Now if I join any two terms using a mathematical operation, this becomes an algebraic expression, right? So this is a numerical, this is a variable, together this is a term, right? And when I have a combination of two or more terms using mathematical operations plus, minus, multiplication, division, then this becomes an algebraic expression. So that is our algebraic expression. So in this chapter, we are dealing with algebraic expressions and different operations on the algebraic expressions. So once you have clarity of what we mean by an algebraic expression, then the operations, how you're supposed to go about, and what are the rules or how to do it step by step is going to be very clear. You will be able to do it without any confusion once you understand what we mean by multiplication of two algebraic expressions, or addition of two algebraic expressions and so on. So in that in that respect, the first thing that we need to understand is like terms and unlike terms. What do we mean by like terms? Now, as I told you, this together this is one term and 7y is another term in this particular algebraic expression, right? Now, we say that two or more terms are like terms when the variable part is the same. Each term has both variable part and numerical part. If the variable part happens to be the same, then they are called like terms. So, what is an example for that? Let's start with 5x that we already have, right? And if I have 2x, 100x, minus 10x, all these are nothing but like terms. That is the variable part, if you look at it, it's the same, right? And unlike terms, the variable part is not the same. So why are we interested in like terms? The first operation is addition, right? So if you have to add two or more algebraic expressions, if it were numbers, then you know how to add two numbers, right? You've already learned it in your previous classes, how to add two numbers. What do you mean by adding two algebraic expressions? So for example, I have 2x minus y plus z. Okay, and this is my first expression. If the second expression is z 5z plus 4, how do I add these two expressions and what do we mean by that? So you will see that here there is one like term. Z and 5z are the like terms, rest nothing is, there are no like terms in the first and second expressions, right? So when you're adding these two, 2x cannot be further simplified. You have to write it as it is. Y, again, there is no other like term like y, so I'm going to write it as it is. When it comes to z, I have a 1 z in the first expression and I have 5 z's in the second expression. So I'm going to add them. By adding, I'm going to get, if you look at the numerical part, it's 1 and 5. So I'm going to get 6z. And then this constant term, there is no constant term in the first expression. So I'm going to write 4 as it is. So this is nothing but the addition of the given two algebraic expressions. That is how you add. Subtraction is the same, very similar to this. Only thing is you need to identify the like terms, and initially, in order to make sure that you don't make any mistakes, we are going to write one below the other, aligning the like terms in the same column, and then we are going to add, subtract. You know how to add. If you know how to add, you will understand how to subtract two algebraic expressions as well. So that is about addition and subtraction of two algebraic expressions. Now let's come to multiplication. So what do we do if I have to multiply two algebraic expressions? Let's take the same two algebraic expressions that we had before, right? So we have 2x minus y plus z, 2x minus y plus z, okay? And I'm going to multiply this with 5z plus 4, okay? For addition and subtraction, I said we'll be looking at the like terms, simplifying the like terms and writing the final expression that will give us the required answer. But what do you mean by multiplying two algebraic expressions? So I have there are three terms here, right? 2x, y and z, right? Minus y and z. And these three, when you have three, it is called a trinomial because there are three terms. And here I have two terms. 5z is the first term, 4 is the second term. So this is a binomial. Okay, if you have one term, it's called a monomial. Right. So based on the number of terms, this is the classification of algebraic expressions. One term is called a monomial, two terms is called a binomial, three terms is called a trinomial. So I have three terms in my first expression and I have two terms in my second expression. So what do we mean by multiplying these two expressions is, now I'm going to take the first term here, which is 2x, okay, and multiply it with the first term here, right? So I'm going to write it as 2x into 5z, right? And then again take the first term and multiply it with the second term. Now this will give me some answer which we'll look at in a moment. And then here I'm going to write plus 2x into 4, right? So the first term here has been multiplied with all the terms in my second expression. So next we will move on to my second term in the first expression. So I have minus y, okay, minus y into 5z, right? And then minus y into 4, right? And then the third term, z into 5z plus z into 4. So if you understand what we are doing here, you will be able to multiply any two polynomials, any two algebraic expressions, be it a monomial, binomial, trinomial, or even higher than a trinomial. You will be able to do it. All you need to understand is you need to take each term in your first expression and multiply it with each term of the second expression. You are going to get a lot of terms, and then you will be simplifying them using addition and subtraction of algebraic expressions, that is identifying the like terms and simplifying it further. For example, if I have xz here, if there is another term which has xz, then it becomes a like term to this, and then you know that you can simplify it, which we have already done in addition and subtraction of algebraic expressions. So that is how we are going to simplify or solve the sums which deal with multiplication of algebraic expressions. So here, like I said, what are you going to get when you multiply 2x and 5z? Now this is nothing but multiplication of two monomials. Now see, I have numericals 2 and 5 whose product is 10, right? And then I have one x and one z. If you multiply x with z, you're going to get xz. That is how you multiply variables. If you have same variable like x into x, you know that you're going to write it in exponent form as x square, right? X to the power 2. Here they're different, so you're simply going to write xz, which is understood, which by convention is product of two variables x and z. Next I have two numbers here, 2 and 4, so it will be 8, right? And then I have only one variable x, so I'm going to write it. Here I have a minus sign, minus into plus will become minus, and I have only one numerical 5, and then I have yz. Here again I have minus into plus minus 4y. You always write the numerical to the left, and then you will proceed with all the variables. So, and then this is 5. Here you have z into z. So, this is going to be z square. And then finally I have 4z. So once you get this form, that is after you have made sure that you've covered all the terms in the first expression and multiplying with each term of the second expression, the next step is to simplify it by identifying the like terms. In this example that we have taken, there are no like terms. So how do you check that? If I have xz here, I'll check whether there is any other term which has xz. It doesn't have. Next, second term is x. Is there any other term with x? No. Then I have yz. Again, there is no other term. Y, there is no other term. Z square, no other term. And z, there is no other term. That's it. This is how you are going to multiply two algebraic expressions that are given to you. Now, after simplifying, you might get a smaller simplified version. If you cannot simplify it, then this is the final answer. So that is all we have in this chapter in your textbook. You will be learning how to add two algebraic expressions, how to subtract two algebraic expressions, and how to multiply two given algebraic expressions. You have 4 exercises. All the exercises deal with this. Although the name of the topic suggests identities, they we used to have it even till last year. In the revised edition, there are no identities given to you. Identities are nothing but those algebraic expressions which are standard, and you can equate it, like for example, if you have a plus b whole square. A plus b whole square is nothing but a plus b into a plus b, which is the product of two binomials, right? And you will see that it is advantageous for you to remember it. It is an identity in the sense you expand it, you will be, every time you can expand it to, you know how to multiply two binomials, you can do it each and every time, but we won't be doing that because you come across it so often that it's advisable that you remember it. So there are a few identities like that which we used to have earlier. So in any later video, I'll try to cover that as well. But as of now, there are no identities given in these 4 exercises. So that's all we have in this chapter. So if you understand what are numericals, what are variables, what is a term, what are like terms, and what is an algebraic expression, what is a monomial, binomial, trinomial, and so on, and identifying the like terms and simplifying, you will be able to apply these operations of addition, subtraction, and multiplication for any two or more given algebraic expressions. So with this, we complete the concept, the theory part of this chapter. In the next video, I will be solving all the exercises given to us along with the solved examples and try this question.